Hi, I'm Kevin Turner, a professor in the Department of Mechanical Engineering here at the University of Wisconsin-Madison. I'm happy to be here today to talk to you about the development of product design specifications. As you know from what you've already learned about the design process, it's extremely important early on in the design process to develop a clear definition of the problem you are seeking to solve. One way to clearly identify the problem and specify it is to develop what is known as a list of product design specifications. So very simply, a list of product design specifications is a list of requirements and constraints that defines the design problem you're seeking to solve. It's very important that you realize that you should develop the product design specifications before you start developing concepts in the design process. So the point of the product design specifications, very simply, is to help you develop a complete understanding of the design problem before you seek to develop concepts. And the hope is that this way your specifications will not be confused by the types of concepts that you eventually come up with in the design process. So what I'd like to talk to you about today, now that we know what product design specifications are and why you seek to develop them, is how we develop them. So first of all, let's talk about where you get information for product design specifications. Usually, when you're presented with a design problem, you'll be working for a client or a customer. And clearly, conversations with the customer or client are one of the first points that you start with in order to develop product design specifications. But also in the process, you might look at competing products, so similar products to what you're eventually trying to design, as well as analyze the market in order to come up with a full list of product design specifications that you can use in your design. So I should point out that there's a set of slides posted on the website just below the video that you're watching now, and this has a full set of slides that follows the points that I'm making throughout the lecture. So now, let's talk about specifically how we write a product design specification. So it's important to remember, again, and I'll just repeat this for clarity, that a product design specification is a full definition of the design problem you're seeking to solve. Simply, it's just a list of all the specifications you want your design to meet. And a very important point about product design specifications is that you want to make them specific and quantitative. That is, we want to keep the specifications to metrics that one can measure. So we'll talk about exactly what makes a good product design specification in a minute, but keep in mind that for each specification that you develop, you clearly want to identify a numerical value as well as the tolerance that you're trying to reach in your design. It may seem somewhat overwhelming at first to think about developing a full list of product design specifications. So the second point that we'll make in today's lecture is that you can easily think about design specifications in a series of categories. And if we start with an initial set of categories, we can break up the problem and make it much more tractable to come up with a complete list of product design specifications. So the final step, beyond coming up with the individual specifications in each group, as well as assigning a numerical value, is also to assess the importance of different specifications. And this may or may not be required depending on how you're eventually going to do your design selection. But you can imagine certain specifications, say ones that characterize the overall performance of the device, are perhaps more important than other specifications such as aesthetics for certain applications. So a useful thing to do after you write your full list of specifications is actually to assign different numerical values that assess the importance of each product design specification. This can be extremely useful eventually in ranking different concepts and selecting a final design. So the 2 points that I want to elaborate on that I've touched on briefly so far is what is a good product design specification and how do we break up a full list of product design specifications into smaller categories to make the problem tractable. So first, let's look at writing good specifications. So now I'm looking at slide 4 in the PDF file that's attached. So in terms of writing good specifications, it's very important, as I said before, that you make these specifications or these requirements of your design specific and quantitative. Okay? And so on the second bullet on the slide, I have 2 examples of poorly written design specifications. So these are very generic for just some product, which we won't define at this time. So for example, you might imagine writing a product design specification such as the product should be fast to assemble and the product must withstand high temperatures. In both cases, these are rather poor specifications. Fast to assemble, while it is descriptive of what you want to achieve, it leaves open to interpretation what exactly is fast. You have a similar problem with just this high temperature. So both of these are not quantitative and don't really tell the designer exactly what the design should achieve. So down at the bottom of the slide, there are a couple examples of properly written specifications. And so these are the same specifications, but written in a much more quantitative sense. So for example, rather than saying the product should just simply be fast to assemble, the specifications should say product assembly should take less than 10 minutes. And so this case is a constraint where we want assembly to take less than some specified value, and in this case it's 10 minutes. It gives the designer a very clear definition of what has to be met. The second one, which replaces the second one earlier, which is the product must withstand high temperatures, says that the product should operate at a temperature of 400 plus or minus 10 degrees C. So this gives a very clear definition of what the expected operating temperature is, 400 degrees C, as well as what range of temperatures might be possible given natural variation in the system. And so clearly, by making these quantitative, we've written much better design specifications that it's easier to assess whether or not a design meets or does not meet. So the final topic that I'd like to talk about is how we think about dividing a full list of product design specifications into different categories to make the problem tractable. So on slide 5, I actually have 20 rather common categories that show up in product design. And of course, you may not use all of these categories for your particular design. This lecture is rather general. You may be a biomedical engineer, you may be a mechanical engineer, or an electrical engineer, and the products you're designing may be very different. And so for each application, some of these categories may make sense, and some may not make sense. But nonetheless, it's a good list to start with. So the 20 categories listed, and I'll touch on a few of these in detail, are sort of meant as a starting point. And so the idea here is that each category gives you a broad theme, and then under each category, you can have individual specifications. So often, the first one on the list, which is performance, is one of the most critical list of specifications. And so imagine you're designing a medical robot, and you're trying to define the performance specs of the medical robot. You could imagine that important performance specs would be the range of motion, the amount of force that the arm can apply, also the resolution, how small of an increment it can move in. Each one of those would be an individual product design specification in the performance category. So when you're all said and done with that application, you may very well have 5 or 6 different specifications under the performance metric, and where each specification clearly defines one requirement of the design. Moving on, there are many other categories on the list. Some are obvious. Size and weight is quite straightforward. Operating environment is often quite important. And when you think about operating environment, you should not only think about the environment that it will actually be in when in service, but also the operating environment during storage and transportation, which can often be quite different than the final location of the product. Product life, how long the product would last. Costs, how much would you like the final device to cost? This can certainly influence design. Production quantity, meaning how many devices you plan to make, as this may influence the materials and processes that you choose to make the design. Aesthetics for an appearance, certainly more important in some applications than others. Ergonomics, in terms of how well humans can interface and how comfortably humans can interface with a specific design. Standards, which is a very important topic for certain applications where there are numerous national organizations and international organizations, such as ASTM and ISO, that have very specific standards for specific applications that must be followed by law in order for a product to fulfill a certain requirement. Other ones include safety, packaging and transport, testing, how will the device be tested or verified, documentation, what type of user manual or other documentation will be provided with the product. One that's becoming more important is actually end-of-life disposal. So if you make a product, you not only have to think about how it will be used in service, but how it will be recycled or disposed of at the end. This is certainly more of an issue as environmental concerns become of greater concern. Installation, competition, meaning other products that you're competing against. If you're developing a new product, you certainly often want to look at competitor specs to understand whether or not yours will have some sort of advantage. Reliability, maintenance, manufacturing, how you'll make it, and then of course existing intellectual property. If you're developing a design, it can't infringe on patents. And so this is a long list, but it gives you a starting point in order to come up with initial ideas for different specifications, and you can fill in as needed under these. And so there are other lists out there. There are many references on product design specifications, and you may look up references on specific product design specification categories for your particular application or your particular field. So I hope this gives a good introduction to the idea of product design specifications. To recap, product design specifications are a complete list of specifications or requirements for a design. You want to be quantitative in developing those specifications. And finally, a very tractable way to solve the problem is to actually divide your product design specification into categories like the ones I've just mentioned here, and then work on developing individual specifications that fall within those categories. So in closing, I would just like to point you to the fact that there are quite a few references available online on the web, as well as in various textbooks that give very good examples of product design specifications. On the last slide of this presentation, slide 6, I've included a reference for a very good website from a university in the UK that details product design specifications, and in particular gives a nice example of a product design specification for a classical mechanical device, a portable winch. The web link is listed on the slide. Also, there's a textbook by Ulrich and Eppinger entitled Product Design and Development, that is the second reference, that has some very good general information on developing product design specifications. Thank you, and I hope this information helps you in your future endeavors.